Hello students, hello everyone. We are still looking at metrics and determinants, but in this video we want to take the correction for lesson 1 and lesson 2 classwork. You know, we run this like a school. In fact, it's a school. After taking the lesson, classwork follows. Then after that, the tutor will do the correction and let you have access to it. Okay. So we take the correction now. That is lesson 1 and 2 correction. Lesson 1 and 2 classwork first before the correction. Lesson 1 and 2 classwork first. So the instruction states the order of each of the following matrices. You have 1 to 4 in that section. Order simply means number of rows and columns in a matrix. The second instruction, how many elements are in the matrix of order. Number 5, 2 by 2, 6, 1 by 3, 7, 3 by 2, 8, you have 2 by 4. So let me explain number 5 with number 1. Number 1 is a 2 by 2 matrix. So number of elements in a 2 by 2 you can take it column wise or row wise. If you take it row wise, the first row has 2 elements, the second row has 2 elements. So you have 4 elements altogether. Or you take it column wise, the first column has 2 elements, 2 and 0. Second column has 2 elements, 0 and 6. So altogether you also have 4 elements. The number 9, given that matrix A is equal to this, find A1 3. That is A sub 1 3, A sub 2 3, A sub 2 2, A sub 3 1 plus A sub 2 3. In the first lesson, you learned the position of element in a matrix. That will help you to answer this question. Okay, we have page 2 of the classwork. Evaluate the following. Number 10 to 12 is addition and subtraction of matrices. Number 13, you are given 2 matrices. Matrix P equal to this, matrix Q equal to this. You should show that P plus Q is equal to Q plus P. That is showing that the addition of 2 matrices follow commutative property. And 14, you should find or evaluate these matrices through the operation of subtraction and addition together So let's take the solution right away. Okay, so solution. The first instruction is that we should state the order of each of the following matrices. So number 1, as I explained earlier, in order you are interested in the number of rows and columns. You must start with number of rows followed by number of columns. So the first two mean you have 2 rows, 2 0 0 6. The second two means you have 2 columns, 2 0 0 6 as well. So it's a 2 by 2 matrix. Number 2 is 3 by 2 matrix. You have 3 rows, that is 3 6. Second row 10 minus 7. Third row 18 4. and you have 2 columns, 3, 10, 18, 6 minus 7, 4. That is 3 by 2 matrix. Number 3 is a 3 by 3 matrix, 3 rows and 3 columns. Number 4, you have 4 by 2 matrix, 4 by 2 matrix. It has 4 rows, S, Y, Z, 1, 2, Z, Y, 3, and 2 columns, S, Z, 2, Y, and you have Y, 1, Z, 3. Okay, so 4 by 2 matrix. The next instruction, how many elements are in the matrix of order 2 by 2? As I explained earlier, you have 4 elements there. The first row, if you are taking it row wise, the first row is 2 elements, second row 2 elements, you have 4 elements. Taking it column wise, first column 2 elements, second column 2 elements, you have 4 elements as well. Number 6, for a 1 by 3 matrix, you have 3 elements. This is a matrix with 1 row and 3 columns. You have 3 elements. For 3 by 2, if you decide to write a 3 by 2 matrix with 3 rows and 2 columns, when you count all the elements, you're going to have 6 elements. Then for a 2 by 4 elements, you by 2 by 4 matrix, you have 8 elements. The simple trick is that if you multiply the elements or the number of rows by column, you have number of elements. In other words, 2 times 4 is 8. Remember, ordinarily this dimension means 2 by 4, but if you want to get the number of elements now, multiply 2 by 4, that gives you 6. Gives you 8 elements. 8 elements. Number 8, that is 8 now. Then number 9, given that matrix A is this, find A1 3, A2 3, A2 2, A3 1 plus A2 3. So A1 3 means the element in first row, third column, that is 7. A2 3 means the element in second row, third column, that is 1. A2 2 element in second row, third column, that is 0. Now A3 1 element in third row, first column is 5, that is 5, plus A2 3, which you know as 1 before now. So when you add, you have 6. You have 6. Okay, so 10, 11, 12 is addition and subtraction, and you know when you are doing this, you have to check to know if the dimensions are the same. In fact, they must be the same before you can add or subtract. So for number 10 is 2 by 2, so the dimensions are the same. So you add minus 1 plus 5, that is 4. That is 4. You have 3 plus 4, that is 11. Sorry, 7. 3 plus 4, 7. The second row, minus 2 plus 0 is minus 2. Then 4 plus minus 1, that is 4 minus 1. You have 3. Number 11, you have 2 by 3 matrices, 2 rows, 3 columns. So subtraction is possible where you have 2 minus 0 is 2, so you have 2 there. 3 minus 5 is minus 2. Then you have 1 minus 3 is minus 2. Second row, 1 minus 5. That means 1 plus 5 now. That is 6. You have minus 4 minus 6. That is minus 10. That is minus 10. Then you have 2 minus 9. That is minus 7. For number 12, you subtract the first two matrices and add your result to the third matrix. So you have 5 minus 2 is 3. 3 plus 1, you have 4. That's a 4 you have here. Then 1 minus 0 is 1. 1 plus 3, you have 4. You have 4. Followed by 2 minus 0 is 2. 2 plus 0 is 2. That is the 2 that you have here. We move to the second row, where you have 3 minus 0 is 3. 3 plus 0 is 3. Still on the second row, 3 minus 2 is 1. 1 plus 3, you have 4. You have 4. Then let's take the last entry in the second row. 1 minus 0 is 1. 1 plus 1, you have 2. The third row, 4 minus 0 is 4. 4 plus 0 is 4. That is the 4 you have here. The second entry in the third row, 2 minus 0 is 2. 2 plus 2 is 4. What do you have here? The last entry, the third row, 2 minus 2 is 0. 0 plus 3 is 3. Are you following? All right. Number 13, you have matrix P and Q. Then show that P plus Q is equal to Q plus P. So you have to take the first one, P plus Q, and you start with matrix P, then plus matrix Q. So you start writing matrix P first, because we for P plus Q. So you add element by element, where you have 3 plus 1, that is 4. That is 4. 2 plus 1 is 3. Then 1 plus 0, that is 1. You go to the second row, where you have the first entry, 2 plus 2 is 4. You have 4. The second entry now, 1 plus 2 is 3. Then you have 3 plus 1, you have 4. You move to the third row, the first entry, 1 plus 1, that is 2. You have 3 plus 2, that is 5. And 2 plus 3, that is 5 also. Then you take Q plus P. In this order, you write matrix Q first. See that now? Matrix Q followed by plus matrix P. If you add element by element, you have 1 plus 3, that is 4. 1 plus 2, that is 3. 0 plus 1, that is 1. You move to the second row, first element. or first entry there. Yes, 2 plus 2, that is 4. 2 plus 1, that is 3. 1 plus 3, that is 4. You move to the third row, first entry. 1 plus 1 is equal to 2. 2 plus 3 is equal to 5. 3 plus 2 is equal to 5. You notice that P plus Q is equal to Q plus P. This shows that the addition of two matrices follows commutative property. Therefore, P plus Q is equal to Q plus P. Are you following? Okay. Number 14, you should find the subtraction and addition of these matrices. If you check the condition for doing that, you will observe that you can subtract matrix 1 and 2 because they have the same dimension, but you cannot add the result to matrix to the third matrix because they have different dimension. So in this case, you conclude that the stated operations are not defined due to different order or size or dimension of the matrices. So you don't waste your time to be adding anything because you cannot. So this is the end of the correction. For updates, follow Petercos Educom via YouTube at Petercos Simplified Math. To do that, if you have not subscribed to this channel, subscribe to the channel, like this video, share the video to your friends, your colleagues, your classmates. Let them know that you are learning mathematics here. You can also follow us on Facebook at fb.me/PetercosEducom, Instagram at PetercosEC, Telegram t.me/PetercosEducom, WhatsApp through this mobile telephone number to keep on having update or receiving update from Petercos education community through the voice of Petercos. So this is the end of the correction to lesson 1 and 2 of matrix and determinant. Take care of yourself, stay out of trouble, and study your books. Practice and practice until you become perfect in carrying out addition, subtraction, and other things in relation to lesson 1 and lesson 2. The voice of Petercos say goodbye for now.